How to diagnose 5V reference problems. This lesson shows how to approach a shared 5V reference fault can create several sensor codes and make multiple systems look broken. A 5-volt reference is a regulated supply the ECU sends out to sensors. It is not battery voltage, and it is not the sensor signal. It is the stable reference the sensor uses to create a believable return signal. If that supply disappears, drops low, or is pulled down, several sensor signals can become wrong at the same time. Many vehicles share one 5-volt reference line across multiple sensors. A pressure sensor, position sensor, and other inputs may all branch from the same regulated feed. That saves wiring and lets the ECU control the supply, but it also means one branch can affect every other branch on that reference circuit. One shorted sensor or rubbed-through wire can pull the whole reference line down. The ECU may then see several unrelated-looking inputs stuck low, even though only one branch is the real cause. This is why replacing the first sensor named by the code can miss the fault completely. The shared voltage must be tested as a network. Multiple DTCs can come from one reference fault. You may see low voltage codes for sensors that seem unrelated: NAP, TPS, pressure, or position. The clue is the pattern. If several sensors lose believable voltage together, the shared reference supply becomes more suspicious than each individual sensor. Use the meter to prove the reference. Measure the 5-volt feed at the ECU if accessible, then at the affected branches. A healthy branch should have a stable reference near 5 volts. If the line is low everywhere, unplugging a shorted branch may let the voltage recover. Scan data helps you see the pattern, but the meter proves the supply. Several PIDs stuck low, several circuit low codes, or a group of sensors that fail together should make you ask what they share. Compare the code pattern, live data, and measured reference voltage before calling any one sensor bad. Isolate branches carefully. With the reference low, disconnect one sensor branch at a time while watching the reference voltage. When the voltage comes back, the last disconnected branch becomes the suspect path. Then inspect that sensor, connector, and harness section before replacing anything. The goal is to find the branch that restores the network. Mistake to avoid: do not replace every sensor with a low voltage code. If several sensors share the same reference feed, one shorted branch can make all of them look wrong. Check what the sensors share. Measure the 5-volt reference. Isolate branches, and watch for voltage recovery before ordering parts. Build the test path in order. Step 1. Review the code pattern. Step 2. Measure 5 volts at ECU. Step 3. Measure at branches. Step 4. Isolate branches safely. Step 5. Verify voltage recovery and repair. This sequence turns the lesson into proof instead of guesswork. STEP Diagnostics. Guided Automotive Diagnostics.